Alright, so today we're going to go over the chain rule. First, before we do that, we are going to go over a few of the other derivative rules that you should already know. Just a quick reminder that the derivative of f or the derivative of g, since these are the two variables that we are going to be using for this lesson, is either f prime or g prime. Alright, so the first rule that we are going to go over is the sum rule. So that is simply f plus g as seen here, and the derivative of that is f prime plus g prime. Next rule is the difference rule, f minus g, and the derivative of that is f prime minus g prime. Next is our power rule. We use different variables here. We use x and n. And the power rule is simply moving the number n to the front of x. That way it becomes multiplied by x, and it becomes n times x to the n minus 1. Okay, next is our product rule. For our product rule, we're doing f times g, and that equals, well, the derivative of that is f prime times g plus g prime times f. And for our quotient rule, we use f over g, and that simply equals g times f prime minus f times g prime over g squared. Another way to remove. Next is your reciprocal rule. We're going to use 1 over f, and this simply becomes the negative derivative of f all over f squared. Our chain rule, we're going to use f of g of x. So first, a general rule for the chain rule. So the derivative of f of g of x equals f prime times g of x times g prime of x. So basically you derive the outside function. In this case, the outside function is f, and times the inside function, and then all of that times the derivative of the inside function. Okay, so for an example, we have 3x to the 5th plus 5 over x quantity squared. So our f function would be everything outside of the parentheses. So in this case, we could say that this equals, well, f equals g of x squared temporarily. So that is our outside function, and then our inside function, which is g of x, would equal 3x to the 5th plus 5 over x. So first we are going to derive our outside function. So in this case, we'll simply be moving our 2 to the front of this equation. So then the derivative of 3x to the 5th plus 5 over x squared is going to equal the derivative of the outside function, as said earlier. So this becomes 2 times, you keep what's in the parentheses the same, so it's 3x to the 5th plus 5 over x. Now that we have done the outside function, we are going to do the inside function, so g of x. So basically for this one, we're going to use the power rule, which we simply move our 5 to the front of here. So as said earlier, we'll multiply it so it becomes 15. And then as if this was n, the exponent is 5. But for the power rule, it has to become n minus 1. And since n equals 5, this becomes 4 as seen here. And then now we do the derivative of the second part of our function. And here we could simply use the reciprocal rule. So the derivative of x is 1. But as said earlier, it is the negative derivative of your exponent of your variable, so it becomes -1, and then remember to add 1 to the exponent on the bottom, so this becomes x squared. And then simply come down here to simplify everything. So the derivative of 3x to the 5th plus 5 over x quantity squared equals 2 times the quantity 3x to the 5th plus 5 over x times the quantity of 15 to the 4th minus 5 over x squared.
The good old chain rule, or as it's sometimes called, at least this is how I first thought about it, was being the outside-inside rule. So this is what the chain rule basically says. It says you start off with a function that's actually a composition of functions, and it says to take the derivative of that. What you do is it's the derivative of f, the inside's left alone, multiplied by the derivative of the inside. So in terms of this outside-inside rule, notice you basically get the derivative of the outside function, evaluate it at the inside function, and then you multiply that by the derivative of the inside function. And that's the basic idea with the chain rule.